Hello, very good morning to all of you students. I hope you all are happy, healthy and fine at home. What did we discuss yesterday? Yesterday we discussed about anti-Markovnikov's addition, that is a peroxide effect, and what is that effect? Let me repeat it again. In an addition reaction, negative part of the addendum or the reagent attached to those carbon atom which carries more number of hydrogen atom, and therefore in this, and we have taken as a suitable example is propylene treated with hydrogen bromide in presence of H2O2 gives 1-bromopropane as a major product. Explain, or what is peroxide effect, explain with a suitable example, or write notes on anti-Markovnikov's rule. These are the, and yesterday we have seen how the mechanism takes place, and that mechanism proceed via free radical mechanism, and therefore we are getting, instead of getting as a 2-bromopropane as a major product, we get 1-bromopropane as a major product. That is the main objective or main thing about that anti-Markovnikov's addition, that is the peroxide effect. And yesterday I have forgotten it. Only anti-Markovnikov's rule or peroxide effect shown by HBr. Only HBr can show as a peroxide effect. And HCl, look at here, HCl and HI. HCl and HI do not show peroxide effect. Peroxide effect, explain. Peroxide effect. Why? Only HBr gives the peroxide effect, but here HCl and HI do not show peroxide effect. What will be the reason behind it? Listen carefully. Once you listen carefully, you will remember it forever in your future. The reason behind it, the reason is HCl and HI do not undergo. HCl and HI do not undergo free radical mechanism. This HCl and HI do not undergo free radical mechanism. No free radical mechanism occur in the HCl and HI, and that's, and they add by ionic mechanism, and these two are add by ionic mechanism. Remember here, ionic mechanism. Here free radical mechanism, they do not undergo or they do not show the peroxide effect. The reason behind it, the HCl and HI, they do not undergo as a free radical mechanism. Instead, they undergo via ionic mechanism. Ionic, you know that ionic means there is a plus and negative charge. So that type of the charges develop between two atoms, and the reaction proceed or reaction takes place. That type of the reaction are known as ionic mechanism, you can call it as a free radical. What is the reason behind it? One reason is HCl bond, and if you compare between a HBr, HCl bond is a stronger. HCl bond is a stronger than the HBr, and therefore there is a no free radical obtained by HCl, because this bond is a very strong bond, and therefore it do not produce chlorine radical. HCl do not produce as a chlorine radical. That is the reason HCl do not undergo as a do not show as a peroxide effect. Now remember, next one is a HI. Now HI can produce as a free radical. When HI, it can produce as a free radical, iodine free radical it can produce, but this free radical is immediately react with another iodine free radical, and one free radical of this and this we are getting as I2 is a molecule here. Here we are getting as I2 is a molecule. Instead of this combination of I on a carbon-carbon double bond, it will prefer to form the bond with that iodine itself, and therefore that becomes as a stable molecule. This one is a stable molecule, and these are the reason why HCl and HI do not show as a peroxide effect. So this is the reason you must remember here. I think this point yesterday we have we continued this why HCl and HI do not show as a peroxide effect. This is the reason over here. Okay, and now we are talking about the addition of halogens, right? And that is the addition of halogens. What do you mean by the addition of halogens? Addition, we know that in an addition reaction, a reaction in which two molecules combine to yield a single molecule of product is known as an addition reaction. And addition reaction further divided into as a three type: electrophilic addition reaction, nucleophilic addition reaction, and the what we can call it as a free radical addition reaction. These are the three types of there. Now we are addition of halogen. What type of the addition reaction it is? It is again the addition reaction similar to as a electrophilic addition reaction. And as we know that the alkene over here, alkene, generally we know that alkene carbon-carbon double bond, right? This carbon-carbon double bond, it is act as a source of electron. Alkene act as a source of electron because there are the two type of the electrons are present, or two type of the bonds are present, and two kinds of the electrons are present. One is a sigma bond, another one is a pi bond, and that pi bond, and it is a electron rich species, and when it is adding with that Br2, or what we can call it as a let us see, here is a general reaction. What do you get? You are going to get the addition reaction seem to be here X, another one here X, this type of the. If you look at the product carefully, I am written one X is above, one halogen atom is above, one halogen atom is below. The reason behind it, the addition takes place. Addition reaction means what? The substrate, this is a substrate, as we know that substrate, or it is a reactant, and this is a reagent, this is a reagent, and both are this reagent completely consumed by substrate. And when you observe the product, what do you see? Whatever atom of the substrate as well as reagent, all are present in the product, and that type of the reaction is called as a addition reaction. And here we are getting as a vicinal halide. This vicinal, what do you mean by the vicinal term? Vicinal means the halogen atom, they are present at one two position. That type of the position is called as a vicinal halide. This is known as a vicinal halide, or they are three bonds apart from each other, or they are 1,4 position, we can call it 1, 2, 3 and 4 at 1,4 position. That type of the system is called as a vicinal halide, or in a other way round you can call it they are present at 1 and 3 position. That type of the thing is called as a vicinal halides. Now only here HCl and HBr only undergoes this type of the halogenation reaction. The halogenation means it is a process of addition of halogen across the carbon-carbon double bond or the olefin. That type of the process is known as a halogenation. Let us see this is a general reaction we have seen, but suppose we have a unsymmetrical CH3CH as usual, that is a propylene, and that will be treated with, as we know that Br2 is a brown in color, and that will be treated in presence of inert solvent like carbon tetrachloride. the reaction just by or simply by mixing these two. One is a propylene. Remember here, this is a propylene, or we can call it as a propene, and this is a bromine. Br2 means it is a bromine molecule which is brown in color, and this is the reaction carried out. This CCl4 is known as a carbon tetrachloride. The name of this solvent is a non-polar in nature. Carbon tetrachloride is a carbon tetrachloride. It is a inert solvent, or it is a non-polar in nature, because the geometry of that carbon tetrachloride is similar to as a methane. Methane, we know that it is a tetrahedral geometry, and therefore methane is a non-polar in nature, even though they are the hydrocarbon. And remember, all hydrocarbon are the non-polar in nature. And as we know that hydrocarbon means what? The organic compound which is made by carbon and hydrogen is known as a hydrocarbon. But here the halide group is here, so most of the students get confused here. This carbon tetrachloride may be as a polar in nature, but not, because the polarity depend upon the geometry of the molecule, and this molecule acquire the tetrahedral geometry, and therefore whatever resulting dipole moment becomes as a zero, and therefore it does not show as a dipole moment, and that's why this CCl4 is a non-polar in nature. Now this is one of the classical method for determination of the unsaturated compound, organic unsaturated compound, or multiple bond is present in the organic compound. This is one of the classical tests for identifying the unsaturated compound in the organic compound. So this is what is going to happen here. You are going to get here CS3, then CH, Br, and then CH2Br. I am purposely written one Br is here, another one is above one. The reason behind it, while they are the addition reaction takes place via different way, and that's why I am showing over here. This is the name of this compound is according to as RUHC. What will be the name of this compound? Can you tell me? Yes, 1, 2 and 3. At 1 and 2 position there is a 2 bromine atom, and therefore we can call it as a 1,2-dibromopropane. That is RUHC name of this compound. Now let us look at the mechanism, how we are, what kind of the mechanism involved in this reaction. So how do we get this product? Let us see here. General reaction, this is in a practical, while performing the qualitative analysis in the laboratory, you are performing as one which is that Bayer test for Br2, and another one is a potassium permanganate, and potassium permanganate also has a pink in color, bromine also has a brown in color, and the bromine at just by mixing or simply mixing these two, alkene and the bromine, at a room temperature in presence of inert solvent like carbon tetrachloride or acetic acid, and there is a decolorization occur, and this is the classical test for the identification of unsaturated compound in a organic molecule or in the organic compound. So this is one. So remember, this is here we are studying as a theoretical. In the practically the chemical test is a very easy, you are, but now you have to know what type of the theoretical explanation, what type of the how the reaction takes place, what type of the product there, whether it is a cis or trans, so or how or what type of the intermediate, because there are in organic organic chemistry, when the reaction takes place, they proceeding via some of the short-lived intermediate are formed, and that intermediate further collapses into the product, and then we are getting as a product. So let us see here the suitable example for the halogenation is this one. I am writing here purposely CH double bond CH2, then Br2 in presence of CCl4, which is known as a carbon tetrachloride, and you are going to get the product CH3, then CH, Br, CH2 and Br, that is 1,2 dibromo derivative. That the name of this compound is a 1, 2 and 3, 1, 2 at 2 position bromine. That 1 and 2 indicate the position of the halide group. So 1, 2 dibromopropane, right? This is a name, correct IUPAC name of this compound. Now let us see the mechanism, how the mechanism takes place over here. Now here, as we know that propylene which is a propylene or the propene you can call it. Generally in the paper are propylene or we can call it as a propene, right? Propene. And now what is happening here? This is acting as a nucleophile or the Lewis base here, CH3 CH double bond CH2, remember, and now their bromine atom Br and the Br, and as we know that these are the bromine atom, when they form, one may get plus delta charge and another one may get as a plus minus delta charge over here. So that type of the thing is shown by the halogen atoms are there, maybe as the interhalogen atoms are there, and that's why they can show positive charges as well as negative charges. And now we know that this propylene act as a nucleophile. It is going to attack on the first bromine. There is a departure of second bromine, and you are going to get the formation of the intermediate like this CH3, then CH, now here Br and then CH2, and then there is a positive charge. 3-member cycle is formed here, and therefore this is called as a cyclic bromonium ion. This one is called as a cyclic bromonium ion. This is a cyclic bromonium ion is formed, which is the intermediate. This type of the intermediate is formed, and now there is a attack of Br minus, and the Br minus can attack opposite to this Br. This Br preferentially is going to attack either this side or this side, and this and when 3-membered, there is a large steric strain is there, and that propane is a very, that cyclonium ion is a very unstable, and therefore when it is attacking either this side or it is a from opposite to this Br, because that Br and that Br here is a, but they are the similar one, and so they create a lot of steric interaction, and therefore these Br prefer to attack from this side opposite to that bromine atom, and that's why we are going to get the product here is this one CH3, then Br, then what we can call it is here is a CH2, and here Br. So Br and Br, the faces are opposite. One is above the plane or one is below the plane. So that type of the mechanism is occur. So this is called as a addition of halogen, or the halogenation, means this type of the bromination reaction takes place over there. And this is a mechanism of this. Following factor support the above mechanism. The following factor, number 1, the kinetic. So let us see, first one is a kinetic here. Kinetics. What type of and as we know that kinetic means we have to determine, we have to measure the rate of the chemical reaction. If you look at over here, in an addition reaction, the rate of this CCl4, it is a solvent, act only as a solvent here. Solvent is not involving in the reaction, is playing just role of solvent over there, so that the reaction carried out. So you will get as a this type of the product formation, and that product is anti type of the products are there, because there are two opposite to each other. The name of this compound 1, 2, 3, that is a 1,2-dibromopropane. First one is a kinetic. What do you talk in the kinetic? Kinetic means determine the rate of reaction, find out whether it is a first order reaction or the second order reaction. While studying as a SN1 reaction and the SN2 reaction, we come across there about that kinetics, right? So what do you see over here? This is a very slow step. Slow step means what? A rate determining step, and this second step is a very fast step. We cannot determine how much time is taken place for the completion of this reaction. But here we can completely determine, we can easily determine how much, because it is a slow step reaction, RDS, rate determining step. Now look at here, before the RDS rate determining step, it depend upon the concentration of the substrate as well as concentration of the reagent, and therefore rate of reaction is directly proportional to the concentration of the alkene into concentration of the Br2, right? And therefore rate is equal to K2 into concentration of alkene into concentration of Br2, and therefore where K2 is a second order reaction, and therefore this rate of reaction depend upon the concentration of the substrate as well as concentration of the reagent, and therefore if you reduce the concentration of the reagent to half or substrate to half, then rate of formation of the product also becomes as a half. That is a equivalent. So that is a second. Now then second point is the effect of the nature of the alkene on a reactivity. Alkene reactivity, as we know that here, look at in the alkene, suppose we have this type of the compound. Second, first one is a kinetic, second one is a substituent, right? Second one is a substituent present on that alkene. And suppose, let us see, this is the simplest one, CH2 double bond CH2. Another one alkene is a CH3, CH double bond CH2. Another, let me draw some of the alkenes over there, CH3, CH double bond CH and the CH3, or what we can call it as a CH3, CH double bond CH and Cl, or CH3, CH double bond CH and NO2 group, like this. And now among these, which alkene is the most stable, which alkene is the more reactive? Absolutely, this is a structure number first, second, then third one, fourth one, and this one is a fifth one. Now among these, what do you think, which one is the most reactive alkene? We already learned this type of the while studying as a carbocation of the alkene, but here just revision of that. So this one simple alkene, but here in the second there is a one group that exerts as a plus I inductive effect, and that methyl group is a electron releasing group or electron donating group. It gives electron to that olefin, and therefore the rate of reaction increases. Now if you look at here, there are two methyl groups are there. They exerts as a plus I inductive effect, as well as look at this is alpha hydrogen atom, hyperconjugative structure. Also decided there are three hyperconjugative structure, and therefore inductive effect plus I inductive effect, as well as what is that alpha hyperconjugative effect, therefore it is more reactive than this. If you compare between this, if you compare between this and this, which one is the most reactive? This one. Ultimately there the magnitude of plus I inductive effect is greater in this case than this one, and therefore 2-butene is more reactive than this one. If you come across this one, here look at on one side there is a chlorine group. When electron withdrawing group present, it will decrease the reactivity of that. Here nitro group is a more electron withdrawing. It has a greater ability to withdraw the electron from that olefin, and therefore it is a least reactive among all these 5 structures, and this is a second last reactive species. This is the least reactive alkane among this. So this is about the substitute. Just remember, if electron donating group present on the olefin, that increases the rate of reaction. If there is a electron withdrawing group present, it will decrease the rate of alkene. So that is a thing over there. And then next one, the effect of added nucleophiles. Effect of added nucleophile. If the concentration of the nucleophile goes on increasing, the rate of reaction also goes on increasing. Now let us look at the third parameter. Here we are discussing what is that the third parameter, which is the addition of nucleophiles. Third parameter is addition of nucleophiles. Addition of nucleophiles. And as we know that nucleophile are the electron rich species, or they are the nucleus loving species. They act as a Lewis bases, and in general, suppose we have this one CH2 double bond CH2, that will be treated with Br2 in presence of CCl4 carbon tetrachloride, and you are going to get here CH2, that is Br, this one positive charge, that is a bromonium ion. This one is a bromonium ion. This one is called as a bromonium ion, cyclic bromonium ion, this form, and further the Br minus attached, you are going to get CH2 Br and then CH2 Br like this. That is a 1,2 dibromoethane, that type of the compound you are going to get. But that nucleophile, if attack in a various way, you will get the difference. Suppose it is attacked by chlorine. Suppose here attacked by chlorine, what do you get? You are going to get here CH2, here Br, CH2Cl. Suppose there is a attack of iodine, I minus, what do you get? You will get CH2 bromine again and CH2I. Suppose it is attacked by nitride, NO3, nucleophile attack. So what do you get? Again it is going to open the ring in a same manner, CH2 here Br and the NO2. Again it is treated with, suppose as a water molecule. Even though it is a weak nucleophile, still you are going to get the product Br then CH2OH. This type of the compound you are. Now can you tell me the name of those compound? What is the name of this compound? You can give the number from this side. Both are the halide, so prefer to give the number from this side. This is called as a 1-bromo, 2-chloroethane. 2-chloroethane. What will be the name of this compound? Again here the number you can give from this side or this side, doesn't matter, 1 2. So at 1 bromo 2 iodo ethane, and the name of this compound is 1 2 or 1 bromo 2 nitro ethane, 1 bromo 2 nitro ethane. This is the RUHC name of this compound, and this is now 1 2 hydroxy is more, so here 2 bromo ethanol. This is the RUHC name of this compound. And what type of the stereochemistry is involved here? Fourth point is the stereochemistry, and as we know that stereochemistry means what? The branch of chemistry which deals with the study of orientation or the arrangement of atom in a space, or study of three-dimensional structure is known as a stereochemistry. And here the stereochemistry is seen to be anti in this case, and there is a cyclic bromonium ion is a form, and we are getting as a that type the compound. I think with this, let us stop today here. In the next lecture, tomorrow's lecture, we will see about addition of hypohalous acid. Thank you. Have a nice day.